Hey everyone, and welcome. Have you ever really stopped to think about how we talk to a computer, how we give it instructions? Well, today we're going to pull back the curtain on programming and get into the basics of how it all works. And to really see just how powerful this stuff can be, let's kick things off with a pretty huge number. Okay, take a look at this. Over 4.2 million. So what is that? That is roughly the number of individual letters in the entire collection of William Shakespeare's works. I mean, think about that. That is just a mountain of text to try and sort through by hand. So let's say I gave you a challenge. I hand you a giant stack of all of Shakespeare's plays and say, all right, your job is to find every single word that starts with the letter A and ends with the letter S. Seriously, how long would that take you? I'm thinking days, maybe even weeks. It sounds like a nightmare, right? Well, a computer, it can blast through that entire job in less than a second. Yeah, less than 1 second. So how is that even possible? That's the big question, and that's exactly what we're going to break down today. And to get our heads around it, we're actually going to build our very own super search tool right here, right from scratch. You'll see how just a handful of simple ideas, these basic building blocks, can snap together to make something that's, frankly, incredibly powerful. Okay, first things first. Before we can do anything, we need a place to hold our information, right? In programming, we use something called a variable. The easiest way to think about it is just like a labeled box. It's a container that we give a name to, and we can put stuff inside it for the computer to remember and use later. So what kind of stuff can we actually put in these boxes? Well, we have to be pretty specific with the computer. We can tell it we're storing an int. That's short for integer, a whole number. Or maybe a float, which is just a number with a decimal point. And then there's str, which stands for string. A string is basically just text. It could be a single letter, a word, or hey, even the entire works of Shakespeare. All right, so we've got our boxes, and they're full of data. Now what? How do we actually do anything with it? Well, that's where operators come into play. These are basically the action words, the verbs of programming. Think of your basic math symbols, plus, minus, multiply. They tell the computer to perform a calculation or an action. Now, this is something that trips up everybody when they're starting out, so it's a really important one. It's all about the equal sign. A single equal sign is a command. It's you telling the computer, hey, take this value and put it in that box. But a double equal sign, that's a question. You're asking the computer, hey, are these two things the same? So one is an order, the other is a question. That difference is absolutely crucial. Okay, so let's get back to our Shakespeare problem. How in the world do we check 4 million letters without writing 4 million lines of code? I mean, that would be insane. The answer is a loop. A loop is our secret weapon. It's like having a tiny, tireless, automated worker that just repeats a set of instructions for us over and over and over again. It saves us a mind-boggling amount of work. And here's what a super simple one looks like. This little phrase here, 4-letter in Word, is a perfect example of a for loop. All it's saying is, hey computer, for each individual letter you find inside this thing we're calling Word, I want you to do something. It just goes through them one by one automatically. But just repeating stuff isn't quite enough for our task. We don't want to do the same thing to every letter. We're looking for specific ones, right? So how do we give our little automated worker a brain? How do we get it to make a decision? We do it with something called a conditional, or what you'll almost always hear it called an if statement. And it's exactly what it sounds like. It's a fork in the road for our code. It lets us say, if this thing is true, do this. Otherwise, do that. It's how our program starts to make choices. And this is where it all comes together. Look at this. We've combined our loop and our conditional. The for loop is the engine chugging along, grabbing one letter at a time. And then, for each letter, the if statement is the brain. It asks the question, hey, is this letter an S? If the answer is yes, we do something, like print a message. If the answer is no, no big deal. The loop just moves on to the very next letter. It's a beautiful little system. So our program is working. It's finding all the stuff we want it to find. Awesome. But where do we put all the results? We need a container for our findings. The first and simplest option is a list. And it's just like it sounds. Think of a shopping list. It's an ordered collection of things. And that word mutable just means it's flexible. We can add things to our list, take things off, whatever we need. It's a great way to keep everything organized in a nice, neat row. But what if we need something a little more sophisticated? For that, we can use a dictionary. Now, don't think of a list anymore. Think of an address book or, well, a dictionary. You don't look up things by their position, like the fifth item. Instead, you look up a specific key, like someone's name, to find its value, like their phone number. It's all about these key value pairs. And this chart really lays it out perfectly. A list is ordered, right? Item 1, item 2, item 3. You get to them using their numerical position. A dictionary, on the other hand, is all about those key value pairs, like a contact list. So which one do you pick? Honestly, it just depends on what kind of problem you're trying to solve. They're both super useful tools. But what if we want to level up our search tool? I mean, really make it powerful. What if we're not just looking for an exact word, but for a pattern? That's where this amazing, slightly crazy-looking thing called regular expressions comes in. And this quote nails it. They are a huge deal in data science because they let us search through massive amounts of data for predefined patterns, not just simple exact text. And here's a little taste of what one looks like. I know, it might look like a typo or some secret code, but it's actually a really elegant search pattern. All those square brackets mean is match any one of the characters inside me. So, with that one little expression, we can find GAT, GCT, GGT, and GTT all at the same time. It's like putting your search on steroids, for real. Okay, so let's put the whole thing together. Let's trace the journey of our super search tool. Step 1, you, the user, run the program and tell it what to look for. Step 2, the program grabs the file and reads it. Step 3, our little loop and conditional engine fires up and starts churning through the text using our powerful regular expression to find every match. Step 4, it saves everything it finds into a nice, neat list. And finally, step 5, it prints the results right on your screen for you to see. Boom. And just like that, we've done it. Starting with just a few fundamental ideas, variables for storage, loops for repetition, conditionals for decisions, we've built a genuinely powerful tool. We took on that digital haystack with over 4 million pieces of straw, and we built a magnet that can find the exact needle we're looking for in an instant. So here's the big takeaway. So many complex problems out there are really just solved with simple, smart, repeatable logic. Now that you've seen the basic ingredients for how we talk to a computer, the real question I have for you is, what problems would you solve with code?